We can solve this question from the standpoint of x-intercepts. If we know that the x-intercept is the place where y is 0, and by the way, the y-intercept is the place where x is 0, then we can start by making y 0, and the y is f of x here. So if we have it looking like this, we can next use the zero product rule, which is the idea that if a bunch of things all multiply together, this, and this, with an answer of 0, that could only have happened if one of them actually was 0. So the next thing we can do is set each piece independently equal to 0. And we'll get x is -6, x is -5, x is 4. So what did we just figure out? We figured out that for the original function, when x is -6, y is 0. When x is -5, y is 0. And when x is 4, y is 0. Now, this piece here is telling us to move down by 3. That's because if you add to the outside of any function, for instance, y equals x squared, becoming y equals x squared plus 5, if you add to the outside, that's a vertical shift. Vertical shifts are normal. So positive is up and negative is down. Adding 5 to the outside is up 5. On the other hand, if you add to the inside, which is the idea of replacing x with something like x plus 5, then that's a horizontal shift, and those are backwards. So positive normally would be to the right, but in this situation, positive's to the left. So this would mean left 5 here. Now, in f of x language, this would be our regular f of x. This is f of x plus 5, and this is f of x plus 5. So now coming back to our question, here we're being asked for f of x minus 3. That's on the outside, and it's vertical, and it's normal. So in other words, this just means we're taking our original graph down 3. If the original x-intercepts are these 3 numbers, our new x-intercepts will now be these 3 numbers, because we're shifting each of these down 3 on an xy axis. And the answer that has all 3 of those points is B here.